So there's a lot of terminology when it comes to test sieve analysis, and sometimes it's easy to miss something or forget something. So in this video, we'll go over everything you need to know, so stick around. Hey there, what's up? My name's Andrew Kotlar, and it's essential to understand jargon used throughout the industry to make the most out of your process. But even if you are a veteran, brushing up on the key terms may refresh your outlook and help you innovate how your lab does things. Regardless, W.S. Tyler proudly uses its 150 years of particle analysis experience to help test sieve analysis lab operators guide their team to take the next step forward. So in this video, we'll go over what test sieve analysis is, key test sieve terms you should know, key sieve shaker terms you should know, and key test material terms you should know. Test sieve analysis is a centuries-old particle analysis method used to determine the average size of particles within a given sample that represents a production line. It involves the use of several test sieves that are placed into a sieve shaker that agitates the sieve, causing the particles to fall through the openings in the sieve screens. It's used by lab operators across dozens of industries, including the pharmaceutical, aggregate, and food industries. Since the accuracy of your test sieves is an integral aspect of producing accurate and repeatable results, it's important that you understand them. So the following are the standard terms you'll come across regularly when working with test sieves. A test sieve is a particle size analysis instrument constructed using a screening medium that hosts precise openings that are uniform in size and shape, which is secured using a metallic frame and skirt. The purpose of a test sieve is to be stacked onto other test sieves to separate the individual particles of a sample based on their size. The term test sieve stack is several test sieves stacked on top of one another to form a single column that consists of various sieve cloth specifications. While the order of your test sieves will place the finest sieve at the bottom, getting progressively coarser to the top, the sieve specifications you place in your stack completely depends on the material you're testing. Sieve cloth is the wire mesh screen that consists of wire diameters and mesh openings that deliver the precision needed to comply with ASTM E11 specifications and ISO 3310-1 standards. When talking test sieves, sieve cloth is generally constructed from either brass or stainless steel, with stainless steel being the more prominent material. The aperture of the sieve cloth defines the measurement between two warp or weft wires that are adjacent. To identify the aperture of the sieve cloth in your sieve, the measurement should be taken from the mid position of the projected plane. The test sieve frame is the component that serves as the main body of the sieve and what is meant when the term sieve height is used. Standard frame heights are 3-inch, 8-inch, and 12-inch in the United States. And it's 100 millimeters, 200 millimeters, and 300 millimeters as a standard size internationally. And much like sieve cloth, the frame is typically made from either brass or stainless steel. The skirt of the test sieve serves two functions. The first is that it's a medium that works in conjunction with the frame to ensure the tensioning of the screen remains drum tight. And the second is that the sieves can be securely stacked to form a sturdy stack. And the frame and skirt are constructed from the same material to avoid corrosion caused by contact between dissimilar alloys. Blinding happens when the individual particles of a sample become lodged in the openings of the sieve cloth or screen. This can occur when a single particle is the same size as the opening or several fine particles accumulate in the fine opening. The pan is a peripheral used to collect the fine particles that pass through the bottommost test sieve in the sieve stack. Sieve shakers come in a handful of forms, each with its own benefits and downfalls. Because these traditional devices are reflected in dozens of industry standards, it's important that you understand the following terms. Sieve shakers are particle analysis equipment that are used to agitate a test sieve stack to help the sample material within it find the screen openings of the various sieves to yield a reliable distribution curve. Mechanical sieve shakers are devices that employ a handful of mechanical moving parts to create a dual brute force hammer tap, oscillating agitation to promote particle movement in the test sieve stack. Despite relying on decades-old technology, these devices are easy to use and, for the most part, automated. Electromagnetic sieve shakers are particle analysis instruments that use a three-dimensional elliptical agitation process to help the sample particles find the openings throughout the test sieve stack. This particular sieve shaker variant relies on minimal mechanical movements, making it much quieter and reducing the amount of maintenance needed. Sonic sifters are a unique sieve shaker that uses a latex bladder to create sonic waves that generate a vacuum throughout the test sieve stack. In addition, the dual tapping motion is applied at the bottom of the test sieve stack. Both the tapping motion and the sonic wave vacuum promote particle movement in the test sieve stack, especially when you're working with finer particles and particles known to become agglomerated. When conducting a test sieve analysis, your results are only as good as the material being tested. To help you with what to expect and what to look out for when working with test material, these next terms are key. Sample material, also called a representative sample, is defined as a portion of that larger bulk of material that makes up the production line. Gathering a reliable representative sample is possibly the most important step in any test sieve analysis, since accurate and repeatable results start with dependable sample material. Agglomerated material is used to describe the occurrence when accumulated clumps form throughout your sample material. This is particularly common when working with material that is either moist, fine, or contains some sort of fat or oil. The term particle contamination is when a foreign material is introduced to your representative sample. When you're conducting test sieve analysis, particle contamination commonly comes in the form of biological matter, metallic fragments, and fibers from clothing. Thanks so much for watching. If you have any questions, fill out a contact us form so we can answer your specific questions. Just click the link in the description. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. Just click that second link and you'll be that expert in no time. And don't forget to click the subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name's Andrew Kotlar, and I'll see you around in the next video. Bye for now.